of a very, I mean, I've been a very good reader since my childhood. And I used to read many books and comics and novels. So there was one comic which I used to read always. It was all about a comic hero named Mandrake. Maybe some of you also have heard about it. Mandrake and Lothar and Diana. So there's a magician. His name is Mandrake, and his wife is Diana, and his friend is Lothar. So I read this comics, I guess, more than 30 years back, and I can relate to what the writer had fantasized 30 years back, or maybe 50 years back, because I read this like 30 years back, but maybe it was actually written longer back in time. So now the story was very interesting. The story is, I'll quickly finish this story in like in a minute or two. So there's a time traveler, a person who's coming from future to the present. The time traveler is basically a thief, and he needs more diamonds to kind of escape to another time. So to do the time travel, this guy needs diamonds. And so he happens to meet Diana, who is wife of Mandrake, the comic hero, and then tells her that he's got magical ointments to to cure her skin and all that. And moreover, he was riding on a cycle, and the cycle was moving without pedaling. So Diana asked, like, how come your cycle is like moving without pedaling? And he said, my cycle tires, they have special gas into it, and that makes it rotate without any efforts. And then she said, well, it could be useful. This kind of technology could be useful for a cycle manufacturer. So why don't you sell this technology to us? And then he agreed. He said, I need diamonds and I can sell my technology. He goes to the cycle industry and then talks to the managing director of this company and says that, how come you have so many people in your company? And he said, it's a factory. Factory is run by man and machine. And he said, no, the factory should be run by machines. The men should be resting in their home, just supervising the operations, enjoying the day, and doing something creative. And he said, wow, if the men are sitting in their houses, how can they work? How can the factory work? And then he said, okay, you give me more diamond and I'll teach you how your factory can work without men. Okay. And then the story goes longer later on. There's a policeman coming from future time traveler again, and then catches this thief with the help of this comic hero Mandrake. The thing is, someone imagined about factories working without men, which I read 30 years back, has been realized today, or is going to realize in near future everywhere. So the basic concept of this industry 4.0, which is the fourth revolution, we call it, is basically to have factories, to have industries working without men. Now the question is, if factories are working without men, what would men do? What would I'm sorry, I don't want to be, I don't want to sound male chauvinist. So what do people would do? Okay, so sometimes people argue, like, the automation and industry 4.0 concept, they are taking away jobs, but that's not the case. Eventually we'll be heading towards a society which is more creative, which will be more in person. So people would get rid of this factory work, which is quite involved and tedious and cumbersome. They get to sit home, and the industry which is making profit will be distributed among the people connected with this industry. And these are the people who would be doing something creative, thinking over, and thinking ahead. So let me take a quick background of Industry 4.0, and then I'll talk about what is Industry 4.0, and then we'll talk about its implementations. So looking from the past, we've seen many era of industrial revolution. There were first, second, third, and now we call it the fourth revolution of industry, which is Industry 4.0. This 4.0 abbreviation was given by Japanese premier, I guess, once in his talk somewhere in UN, and then it became popular. So we'll also see what is common in STEAM, science, and digital technology. So, a revolution basically means there's a drastic change. There's a there's a quantum leap in the technology. Unless there's a quantum shift or drastic change, it is not a revolution. It is rather enhancement or improvement. Now, the first revolution that we observed, that we witnessed, probably was from foraging society to a farming society. So people were dwellers. Forest dwellers, like they move randomly, dwelling in the forest, would eat whatever comes in their way, and that's it. And then from that era to organized farming and exchanging between people and in different places, it was a long history in humankind. Happened around 10,000 years ago, and farming can be taken as a first revolution. I know. Now, from farming, we move to machines once James Watt invented steam engine. And so everywhere we could see, from agriculture to the textile, they were all industries, big industries where you had, room-sized machines, and the machines were operated on steam. So there was another boiler kind of device which would create enough steam for these units to work. So it started from industries and then came down to the transportation. We saw steam engine, steam locomotives. There was even steam operated buses flying into the cities. I remember I come from Jaipur city, and my father says that back in 1950, there used to be steam buses flying in the city, taking people from one place to another place. So this steam power uh, actually revolutionized the industries. I mean, in fact, the steam was the cause of the industries. The industries started from then after the invention of steam and the machines, and so people started coming over to the cities and started living over there, and centralized production of many things started. So later, the cities grew more and more, and so the industries as well. And but the conditions in the factories were very difficult. The laborers coming from villages, they were cheap. There were many, but they were working in very unsafe conditions. There were many accidents. Even children, they used to work in longer shifts, and so these conditions continued until the end of 20th century. And then there was a class of middle class. I mean, there was a middle class of skilled work that emerged out, and together with the invent of electricity, uh, again there was a revolution, because many of the processes which were dangerous and difficult and cumbersome and repetitive, they were automated. As you can see in this picture, it is a picture from 1930 from the one of the workshops of Ford company, Ford Automobiles. You can see people uh, sitting across an assembly line and putting together the magnetos and the flywheels. So this automation, because of the electricity, was again a kind of revolution, and it changed the way people were living. People started migrating to the cities, as compared the U.S. population that lived in cities. In 1800, it was only 6%, which became 40% in 1900. So can imagine, like 40% of the US population started living in cities in 1900. And then, so it was all for the sake of centralized production and many jobs that were available. It was all the gift of um, advent of the electricity into the factories and the consequent automation. Now later in 1990s, it all started from 1960s, I guess. And then we saw a lot of automation happening. We saw the advent of robots. We saw the automation of digital computers. Now, with the computers and these automated controllers like PLCs and 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 um, and PIDs, so what what actually we could see was less people working in in more dangerous places. So especially jobs that were monotonous, repetitive, required more accuracy, were hazardous. It was all given to the robots. And with the robots making things, we were heading towards more accuracies and increased production based on these assembly lines. That was also considered as a big revolution in the industry because, um, as you can see, we actually moved from analog to the digital world. So we had these analog machines, but then analog machines were governed by digital systems. And then later we started talking about cloud and internet and mobile devices. So staggeringly, different technologies were kind of helping the industry, but they started helping the industry collectively only when we started talking about this industry 4.0 concept. So the technology was existing. When technology was existing, but there's always a point of acceptance of technology into the society, into the industry. And that point would only come in 2000. So starting from 2000, there was a big revolution where electronics and information technology began to automate the entire production line, and it also affected our supply chain globally. So what we see present day is that we have interconnected mobile devices. Like everybody in the world is interconnected. Okay. When I was very young, very small child, I used to think that people are interconnected, and I used to think that okay, the president of India is connected to me somehow because I know some people, and some people know other people. These other people know many other people. So we are actually connected. The only thing is we don't realize. Now this era with the devices like we have mobile phones and internet and laptops, we can actually see that how on LinkedIn we are all connected. On Facebook we are connected. On there's so many social platforms where people are connected. So we have devices to connect people all over the world. The processing power and the storage capacity, and access to knowledge has increased. It has become pretty difficult these days to teach students because the students we teach, they have access to the entire knowledge that they are aspiring for. The knowledge may not be available in the form that they are able to understand, and that's what a teacher's role has become now these days. You know how they say that a picture is worth 1,000 words, and then we started saying that a video is worth many thousand pictures. So with the help of all this, things are. I mean, the knowledge is becoming. It's coming on your hand. It's quite handy and it's quite accessible. We're talking about artificial intelligence these days, which is helping us in every sphere of the work. Talking about robotics, I mean, we are still in the transition phase, but times to come, we will see many robotic gadgets in households, in in public sector like healthcare sector. You would see this into the malls and everywhere. We're talking about um, this 3D. We're talking about uh, 3D printing rather, which has revolutionized the manufacturing. Then we're talking about nanotechnology, which can make up the complete system into a very small device. We're talking about quantum computing, which can help us in carrying out calculations that otherwise were only possible on GPUs and or high performance computers. With the help of quantum computing, it will be possible to miniaturize the entire CPU so much so that you can hold it on a fingertip. we've been talking about Internet of Things. We're talking about autonomous vehicles. We're talking about UAVs. Uh, I mean, there's endless applications of these technologies. Like UAVs, they can provide you internet at remote locations, and it has been experimented. It has been done. UAVs are providing, infrastructure where it is not available in very remote areas, and then they're also helping uh, in transportation and logistics. We are talking about energy storages and compact batteries, and then the material science is also improved. So we have these improved solar panels, and materials are, they're novel and improved, and good quality materials helping us in every walk of life. So this industry 4.0 that we're talking about, as I said, the word was coined by a Japanese premier, but it was actually implemented in Germany. Um, so in one of the companies in Germany, they started calling it industrial Internet of Things. So they were using internet in their industries, and they thought maybe it's a good word. I mean, they thought they were doing internet in their industries. So they started calling it industrial Internet of Things. So it became IIoT, and this IIoT later on finally became the industry 4.0. Now, these industrial evolution, um, what I've described before, can be summarized into these with this figure which you see here. So, end of 18th century, we finished with the first industrial revolution, which happened, which occurred due to the steam technology, and then we had electrical energy, and the second revolution, which ended by the end of, beginning of 20th century. It started, and kind of, it was transformed into a third industrial revolution with the advent of electronics and autonomous devices such as robotics. And then these days we are in the era where we kind of observing a fourth industrial revolution, which encompasses many things together. So it's just not one thing. Like, previously we had either it is steam or electricity or computers, digital computers and the robots. But this time we have many things to put together and call it a fourth industrial revolution. But as I said, the ultimate aim is something that a comics writer envisaged 50 years back, was that we want to have industries working without men. They also call it lights off industries. So there's no human soul inside the industry, and the entire industry is working on its own, inside, outside, and then people are meant to be um, doing something creative. So it's not that they are getting, you know, their jobs are taken away, but they are still paid because they are connected to these industries. Their job is now to think ahead in time and do something creative. It's the same story again, but what we say in future is that this industry 4.0, it's going to deliver unprecedented levels of growth. Yes, we're talking about something close to 150 billions by 2025. And the success of this industry 4.0 is something which we are already familiar with. We have been using Amazon, we've been using Netflix, eBay, PayPal, and these are the living examples of the implementation of Industry 4.0. Now, these are the examples that we see are basically they fall in the category of B2C. This is to customers. What we don't see is B2B. And if you look at B2B, they are far more impactful than B2C implementation of Industry 4.0. Later, maybe if time permits, I'll talk about this. But if time doesn't permit, maybe tomorrow when we meet again, I would like to talk about this business to business impacts of Industry 4.0 and how Amazon web service and Google and others are, the main earning comes from those kind of things. This Amazon customer service is just for their popularity and publicity. But there are other sectors of industry such as manufacturing, agriculture, energy, aviation. Everywhere we would see the impact of Industry 4.0, how significant it's going to be. Now, people sometimes question that what we are achieving out of implementation of Industry 4.0. But then there are people on the other side who would argue that even if you could improve your functions by 1%, it can significantly impact your gains. And to support their argument, they do have examples on their side. For instance, in aviation industry, if you can achieve fuel saving of 1% per annum, that amounts to a saving of $30 billion. I mean, for those who cannot imagine this, 30 billion would mean three zeros. I mean, 30,000 million, and 30,000 million would mean again 300,000, 100,000. So 3 lakhs of lakhs dollars, which is huge money. Similarly, if you consider 1% fuel saving for the gas-fired generators in power stations, worldwide can give you operational savings, just the operational savings of $66 billion. For oil and gas industries, which is number one when it comes to the revenue in the world, if they can reduce 1% of their capital spending on equipment somehow, it could mean earning of $90 billion for them, and goes on for everything everywhere. Just 1% improvement can do significant gains for industry. Think about what Industry 4.0 can give us. So, why we need this Industry 4.0? What is driving this Industry 4.0? So now I'll talk about some of these driving indicators before actually jumping into what is Industry 4.0. So why we have Industry 4.0 is because of these two kinds of economies that are coming up. So these days we talk about a networked economy, and also we talk about a digital economy. I'll first talk about what's a networked economy. So definitely you must be thinking right. This network that I'm talking about is the network of human, is the network of people around, and the network of people at the lowest level, and then we have network of communities, a network of companies, a network of businesses. So this is the era of networking. When we go on a social networking site, we know each other. That's another kind of networking. Now, if you look at this bathtub curve, if you are able to see this bathtub curve, I hope everyone can see what's on my laptop screen in this bathtub curve as well. So on the y-axis, what I have is the contribution of men. I mean, if you go above, if you go further in the positive side above, the involvement of human being is increased, and if you go downward, it's the involvement of machines that is increased. I hope you understand this. On the y-axis, I have the involvement of man and machine. So if it is increasing, then this shows involvement of men, while a decrease shows involvement of machines. Fine. On the x-axis, I've got the time scale. Now let's talk about the industries that were there before 1900, and we all know that we had artisans, we had craftsmen, we had weavers, we had carpenters, and these were the classes of community that were making goods, that were making products for subjective needs. So they were very specific kind of products that they were creating, and they were crafting. So, and it was done by the local and small artisans. So here we're talking about um, specialized and specific products. Now, I mean, you go to the carpenter and tell him that I need this kind of a device, and he would make it. This kind of a furniture, and he would make it. You go to a goldsmith and tell him that you want this particular kind of jewelry, and he would make it for you. Now, from a very specific kind of product making, later with the advent of machines, we move towards generalization of products, where we were creating many copies of similar kinds of products into the factories. And that era, it actually lasted for close to 100 years. Now talk about what after 100 years again now. Now this is the time again that we are entering into our past, where we were once again, we want, very specific subject oriented products. And we why we are heading towards customized products is because it is possible now. I mean, at the time when it was not possible, people didn't have many options. They had to purchase those generalized items. But now it is possible that you want something unique, and you tell the company, and they would make it for you. So this customized product era has come back again, but it has come back with more accuracies, and still it has involvement of machines. So previously they used to think that because the many machines were not modular, they were not adaptive, you could not make different kinds of products on the same machine, right? You could only make a particular kind of product. But with the advent of this industry 4.0 that I'll explain later, it is possible now to kind of customize products as per the requirements of the customer. For instance, if you go to Amazon's website and type door, I mean room, every room has doors, right? A door like this. If you type door accessories, you would see hundreds of items that you had not imagined even. So there are people who needed something, and they asked for it, and that was the driving, force for factories and for small manufacturers to come up with these kind of innovative products. So the business models, if you talk about in the network economy that we are talking about, the network economy is like, because we all connected, and because we are connected, we know each other's requirement and can make it as per the requirement, right? Now, and then there's a sharp contrast from the industrial economics to the present days businesses. When you talk about the ownership, so previously we used to have a company who was owned by a family or a person. Nowadays, the concept has completely changed. I might be selling something which was previously owned by some other person, and he was again not an original owner of it. So we keep on adding value to the product and further sell it to more customers. So there's no concept of a single owner now. A product given can be owned by many people who have added value at different stages. Now, when it comes to such kind of a varied ownership for products, it gives rise to many issues such as like who owns the right for this and all that, and it makes the entire thing more complicated. But then there are ethics, and there are rules being structured for such kind of economy, and this is happening because with the help of this digital economy that we'll talk about later. So the two things, they're working together: digitalization and digitization and the network economy. Now, what do we mean by digitization? Basically, it's like you can, in a single word, call it internet economy. These days, when you go to purchase something, You just purchase it, scan the code, and pay it, and then that's it. Now, what's happening is the economy is turning to be a web-based economy. So where people, they're all connected, billions of people every day, they talk to each other, they're connected to each other. I mean, they don't talk to each other through their mouth. They communicate with each other through many devices. So FPOS devices and those um, Q code device, Q code printed on sheets. So these are the things we are communicating with each other, and how people are connected together. So the economy has suddenly become, I mean, it's kind of a digitization of this economy, and which is also networking. So previously we used to talk about like B2B or B2C or whatever, but these days there's no such kind of concept. Everybody's connected to everyone. So well, we are able to connect to the businesses. We can also go to a retailer, we can also go to a wholesaler, we can also connect to the company directly and get things done there. And a customer can also be connected to the devices, and the economy is driven. So there were a few, laws defined by earlier thinkers and philosophers, scientists, that we are able to witness now, like Moore's law. Everyone knows that he said the processing power of microchip would double every 18 months, and that's something which we are observing. At the same time, when the processing power is increasing, the cost is also being halved every 2 years that we can see. But over the time, I guess there's a kind of saturation, and there would be once again some new technology coming in, and there will be again a quantum leap of technology. Now, Huntley's law says that the investment in IT products and platforms is usually 10 times higher when you compare to the production of traditional goods. And this is a reality. And this is, again, a driving force for a digital network economy. Gilder's law is quite popular. He said that the total bandwidth of communication system, it had to be triple every 12. You need to increase the bandwidth of communication. Otherwise, so there are two ways to have enhanced communication. Either you increase your bandwidth or you lower down your bandwidth requirement from the communication protocols. And then this Metcalfe's law, it says the value of a network, this is very interesting, the value of a network is proportional to the square of the number of nodes. So we all link together through, there's a website, there's a platform called LinkedIn. I started this, I joined this back in 2007, I think. By that time, it wasn't that popular. But nowadays, you see, everybody's on the LinkedIn. Now, your value, why I get so many notifications and requests, because if I have many people linked to me, so I would get more requests. So it basically adds value to my network, and this value basically can actually evaluate it, and we can actually quantify it. It turns out to be the square of the number of people you know, and the same goes for business to build the business network and the social networking sites, and these are the things that are driving our economy today. So because a social network, we're all connected. Person sitting in India and US and Canada, they are not sitting in islands anymore. Physically they might be sitting on islands, but virtually they are all in the same world. In the same world where they share similar things, they share similar knowledge, they share similar uh, products. And so when a person in Canada uses a certain kind of product, it doesn't take years to come to India. Or when a person in India has made some new device, it doesn't take long to reach this device to other parts of the world, and especially in China, they would copy it quickly. So with the social networks, it was one of the driving force, of course. And then the business networks, again, they have very specialized business networks. Even if you open your WhatsApp, it says that the WhatsApp has a business version. You have all these social networking platforms, but then they also have their own business versions, which are a bit expensive, slightly expensive, but they have more facilities, more features. Now, these networks that we have, these are the driving force for this industrial Internet of Things. It has been said that the number of, there's going to be another rule plans to come. It has been said that number of connected devices, it may increase 30 times in a decade. And it is being seen. As you can, I mean, I've taken this data from reliable sources and says that in 2009 there were 900 million connected devices. See, when we're talking about the connected devices, what we mean is the devices are connected through internet, or they are communicating with each other. So basically, we had, I mean, previously we had only computers which were connected, and then we had these microchips that were connected, and then we had tags, these RFID tags that were connected uh, throughout the world. I mean, if you go to any shopping mall, try to purchase something. Nowadays, every product in the that is arranged into the shelves, they have a small device attached to this product, and this device has an RFID tag. So when you purchase something, you take it to the counter. The person sitting on the counter would take this device out of your product and then will give it to you. I mean, if you don't remove this device from your product and try to take it outside the mall, there are sensors who can sense this RFID devices and they will give a beep sound that this tag has not been removed, or maybe this has not been paid off or whatever. So, sorry. So it is envisaged that okay, yeah, it is predicted that in times to come, like by 2022, there will be 35 billion devices which are connected, which will be connected, and it doesn't look like a fantasy, because even today, if you look at the statistics, it says that 26 billion devices are already connected. Now, okay, I just want to read the chat messages that I have here. Okay, maybe let's see. So if you have any question, maybe you can interrupt me and you can ask me, and I'll try to explain. So the network economy that we talked about. Now, there are industries who would like to, stay in the business, and to stay in the business, they need to make some changes. They need to be mobile. They need to be connected with the society. They need to be social. They need to be always on, and they need to be continuously connected. They say that if you cannot make money while sleeping, it's not a business. You're not doing any business if you cannot make money while you're sleeping also. Now, so the businesses, they need to be engaged with the external businesses and the internal networks. Take example of these. I've only listed down these 4 companies, but there are many more. And these are the companies who actually have taken benefit of this network economy and have risen to like top 500 companies in the world. For instance, talk about Airbnb. So you go to any part of the world, and if you want to stay in an apartment or a hotel or anywhere for lodging and boarding, Airbnb can help you. For me, whenever I go to UK or US or Canada, all we do is like we book an apartment through Airbnb. They're very cheap. So how do they do is, Airbnb is only connecting people to people. So I have an apartment, let's say in Jaipur, but I'm not living here, and this apartment is empty. I want to rent it out. So what I'll do is I'll put it on Airbnb. So someone else who is visiting, who's coming to Jaipur for a short period, will be connected to me through Airbnb, and I can rent him my apartment. And it's happening in India as well. When you go to different cities, if you book your accommodation through Airbnb, it's cheaper, and it's bigger, and it's better. Google Page, on the other hand, it helped many drivers, and it is helping drivers, especially in the US. Uber and eBay are another example of connecting people. They're only connecting taxi drivers to the user, and that's it. Their job's done, and making lots of money. So now, so these were the things we were talking about. These, drivers, and so we discussed about the drivers of Industry 4.0. I mean, what were the things that were driving implementation of 4.0, Industry 4.0. Now we'll talk about some of the things that have enabled um, this Industry 4.0. These are the enablers of Industry 4.0, and something that comes to our mind first is the data. Why we talk about data is because in industries these days we use a lot of sensors, and that's the only reason that that we have a lot of data. Uh, you should not think sensors as if some alien kind of thing. It's quite close to you. It's quite close to you. You use these sensors every day, every time, and there are many sensors that you already have in your mobile phone. Okay, the mobile phone has got gyros, it has got camera, it has got uh, many different kinds of sensors that create lots of data. I mean, think about this camera alone. I mean, how many pictures that you take every day, and how many pictures that you download from other sources. So you have lots of data in your small mobile, and you're worried about this data, and you want to delete it to get rid of your memory, and to refresh your memory and save on memory. It's just the mobile phone that you have, and there's so many sensors and there's so much of data. Think about a computer, which is in a hospital or industry. It is collecting lots of information. So different kinds of sensors. Uh, of course, we have progressed thanks to Moore's law. We have many. We were able to achieve miniaturization of electronics, and this miniaturization of electronics has enabled us to store more and more on a tiny place. But this more and more is creating problem again, because you have more and more data. How do you handle the data? Either you don't handle the data, just let it go, and that's the cost of loss of opportunity that you might be ending with. So those who are able to make good use of this data that is all around you are able to uh, get an edge over their competitors, because it is the data that can give you information which can help you making good decisions. But once again, when it comes to data, the analysis has to be systematic. It has to be in a planned manner. You should know what kind of analysis you are doing. So basically, there can be a descriptive analysis. A descriptive analysis says that what has been. Okay. So when you talk about a descriptive analysis, what basically you're doing is you're trying to analyze the data that you have collected, and then you give a picture of what is happening. Now, based on what is happening, if this continues further, what will happen after 5 years or after 5 months? This kind of analysis you're doing, it's called predictive analysis, right? Now, if you're not happy with this predictive analysis and says that if you continue like this, you're not going to achieve your targets, and you're not happy with this, you want some interventions, you want something to be changed, you want something to be improved, then there's still one kind of analysis on this data that you can perform, and it's called um, prescriptive analysis. So with the prescriptive analysis, you are able to see what needs to be changed here in the present, so that your performance will be better than what is predicted in future. So it's a lot of thing in this data and data analysis. The other thing is connectivity. The connectivity it's all because of this. You have more database access and RFID I was talking about. So there are many sensors which are kind of sending data all over, and through communication of data, they are connected. So this connectivity is again a big enabler for Industry 4.0. If we don't have such kind of a connectivity, it's not possible to implement Industry 4.0, and it wasn't possible to think of Industry 4.0. So uh, previously we had issues with distance and time zones, but with this kind of virtual global platform that we have now, it's possible. It is possible to avoid all these problems and okay, let me check. There's some messages. Okay, fine. Now, the next enabler I'm going to talk about is the customer. So the customers, they are putting up their customized demands, and how do you fulfill those demands? Talking about 10 years back, we were talking about management information system, and then we used to talk about um, product design stages based on MIS. And so there we were talking about that first do a need analysis into the market, go to the people, go to the products, not to the people, go to the products, what is available and what people may require in times to come. And so you do a need analysis. And then based on the need analysis, you conceptualize a design and then try to make a detailed design and then give a product and make people realize that they need it. So previously we were thinking of design of products in a direction that we want people to realize that they need something. The time has changed now. Now the people are coming up with their demands and they tell you what they need, because their needs are more now. Their needs are more specific. They're more customized. And because they are more customized, you need to have your production systems which are adaptable, can customize production, and it can only be done through the help of digitization and implementation of Industry 4.0 concepts. Now, I'll talk about these three horizons of Industry 4.0 implementation, and then we'll talk about what are the um, building blocks of Industry 4.0. So here we're talking about the horizons of implementation. There are three horizons of implementation of Industry 4.0. I mean, the first requirement for a business is initial connectivity. So until unless there's a business, it is connected with other businesses through internet, it is not possible to move ahead. It is not possible to have Industry 4.0 implemented. But once you have this connectivity, then there are three horizons which are required, which kinds of makes up, which kinds of facilitate um, implementation of Industry 4.0. These horizons of implementations are process optimization, process flow and quality, and then new business models. So first, we need, industry going into implementation of fourth revolution, they need to first optimize their own processes, and then later they need to emphasize on the flow of the process and the quality of the product and the process. And then they have to think ahead in time to create new business models. So let's discuss these three horizons quickly, and then we'll talk about the building blocks of Industry 4.0. So the first horizon, as I was talking about, is the process optimization. Obviously, the processes may not be quite efficient. They may require, we want to head towards more cost saving. So this optimization of process is directly related to the cost saving. Now, what happens if your machines are not maintained in time and they're heading for a breakdown? Now, suddenly you have a breakdown of a certain machine, which is very crucial for your production line. So the entire production line is stopped. And now repairing the machine would take 3 days. It's a loss of 3 days production plus uh, the job order plus the loss of credibility. There's so many things that you lose in the process. So basically, if you want to do an optimization, what it means is your process should be optimized. Obviously, you want to see that uh, that, the processes can be carried out in the minimum time possible. That's fine. But at the same time, we want to optimize the performance of machines as well. So what does it mean is that we want to maintain them. We want to kind of do a predictive or rather a proactive maintenance onto the machines so that they don't uh, they don't get broken and the processes are not halted. So that's important to to optimize the process. It may be like you want a single person to carry out many operations. Let's say on the cost of the salary that you're paying. But once again, as I said, the process optimization is quite subjective task, and people they need to identify. The industry has to identify what processes and uh, what are the areas where they can perform optimization and they can save on cost. But then to identify again, you need a lot of data, and for that you need sensors, and of course, Industry 4.0 can help in that sense. Now, so when you collect a lot of data, right? Now you're collecting data, but by the time you collect data, maybe it is too late to kind of take making decisions. So the entire process they should be run in parallel. And so when we talk about Industry 4.0 and its horizons, so one of the horizons is process flow and quality, which is about creating a digital thread. Now, this digital thread is very important uh, because from the data, right from the census data, to the decision making and implementation, the entire digital thread has many processes uh, that require implementation industry 4.0. And so the entire process has to be you need to look into the process flow of this digital thread that runs out the entire process and also maintain the quality of the product. So of course it's going to be taking very long, but eventually uh, for quality and for increased visibility into the market, it is essential. And then, as I said, you just can't sit back and relax. You need to always think about new business models. Uh, Many of the companies that we see today, they were not existing 20 years back or 10 years back, even. Or the businesses that we see, that we saw 20 years back or 10 years back, they don't exist now. So it's a kind of struggle to kind of formulate new business models. It's a continuous endeavor that people will have to do. Now, if we have further queries in these three horizons of industry, here's an example. Here's an example that shows what these three horizons mean. So when you talk about process optimization, it's basically that we are talking about operations optimization, predictive maintenance, uh, employment of robotics and additive manufacturing, consideration of safety, inspection and testing. These are the areas where optimization can be performed and can actually enhance, can lead to cost saving and enhance performance. The process flow and quality, where we talked about the digital thread. So the digital thread should have everything starting from sensing and imaging to IoT platforms and connectivity, supply chain, and on top of everything, cyber security. And then for new business models, of course, with the data that we have, that we collect, um, and then the products that we design based on the data that we have, will certainly lead to new business models. I'll talk about a very good example on this later on. Yeah. So the most sought after capabilities of Industry 4.0, if there's an industry wanting to implement tenets of Industry 4.0, they need to look into these four aspects more specifically. For instance, this predictive maintenance is very important. At the same time, operations management, they need to be carried out. Your operations inside, outside, they need to be optimized, and to have more visibility into the process, um, more visibility into the process. This sensing and imaging is important. And then cybersecurity is of course important because you want to safeguard your interests. Uh, Implementation of Industry 4.0 is a practical subject, and if today, maybe today or tomorrow, I'll share one small video that I have my own experience with the Industry 4.0. But to let you know, uh, there's a group of industries in Gujarat. It's like 300 plus industries that have grouped together, and using a very famous consultant, these companies are trying to implement Industry 4.0 to compete with their competitors worldwide. So any kind of industry, I mean, there's no restriction on type of industry for the implementation of Industry 4.0.
Sir, excuse me.
Yes.
Sir, we are facing some disturbance in the audio system. Is it from your end or?
Are you able to listen to me?
Yeah, we are able to listen to you, but some disturbance is coming in the audio section.
How about, is it better now?
Yes, sir. Yes, sir.
Is it better?
Yes, sir. Yes, sir.
Or this? Do you mean this knocking sound?
Yes, sir. Yes, sir.
Ah, just give me 1 minute. I'll try to stop it. Wait a minute. So maybe we can break for 2 minutes and then.
Yes, it's okay, sir. No problem.
So by the time it is being carried out, maybe I'll try to make it. Yeah, someone should go upstairs and stop this sound. It's irritating. ऊपर से आवाज आ रही है वो बंद करवा जल्दी. Thank you. That's for half an hour. Sorry for that. Okay, let's continue again. So basically, what I'm talking about when I say Industry 4.0, we are talking about a factory that is, as I mentioned, it's kind of lights off industry. There are no lights because we need lights for human to see. Machines they don't need lights to see. So for complete lights off industry, the machine should be capable of doing work. I mean, working on their own. When you say the machine should be working on their own, it is only possible. Sorry, it is only possible. It is only possible if the machines they have all the capabilities of uh, sensing, making decisions, and actuating. So these three important functions which I'm saying. I mean, sensing is to understand the environment. Uh, Making a decision is based on the controllers that the machines would have, and then acting upon is is, is because the machines should have some actuators on it. It could be a motor or anything else. Now, let's think of an assembly line where a product is moved on different machines and different operations are being performed onto the product. Now, when a product arrives at a machine, the product would have some kind of a tagging. Okay, product would have some kind of RFID tag, and the product is talking to the machine, telling everything that has been done onto the product and what is expected from this machine. And then machine would come to know, okay, I'm supposed to do a drilling operation, or let's say a stamping operation or whatever. The machine would do that and would also record the information of the process being carried out into the product's RFID. So the machine has got a controller. So now machine is interacting physically with the product, perform the operation, and then the machine is interacting with the product digitally through its own computer system, sending out the operations performed onto the product, which gets stored into the uh, information that we have for the product. Now the product moves on to the next machine, and it carries information of the operations carried on to it the previous machine, and it goes on. So here we're talking about, I mean, there's a communication between the machines, there's a communication between machines and the product that's inside the factory. And then outside again, the machines, they need to be talking to the inventory, because they cannot produce more than the inventory needs. The inventory needs to talk to the warehouses need to talk to the customers, and I mean, it goes on. So everybody is connected. Now, how they are connected, how they can be connected, you cannot do a miracle, but the thing which connects everybody is called cyber physical system. So every entity that we have in this industry 4.0, or every entity that we have in this industry which has implemented post revolution, so all the components, they have to be converted into, from physical system, they have to be converted to a cyber physical system. Now, the cyber physical system, sorry, it can be just about anything that has integrated computations, networking, and the physical process. So physical process is already there. Of course, we know the drilling machine has to do the drilling. That we know already. But then it should be able to network itself with other machines and the products inside the factory. And on top of this, the machine should also have a small platform of computing platform where it can carry out the computations of the information carried out. For instance, you have a particular kind of product coming to the machine. Now suddenly there's a different kind of product comes to the machine. The machine should be able to calculate, compute what are the differences and what are the different operations need to be carried out. So this CPS, or cyber physical system, is the basic entity of Industry 4.0 concept, and that converts every entity. And I just talked about a machine, but a small component in industry is also can also be defined as CPS. For instance, there's a bin which carries all the goods and moves on a conveyor belt. This is again a cyber physical system, and the capabilities can vary from very high capable CPS to a low capable CPS. It may not have a computing, but may have it has to have certainly a networking and a physical process components. So this is what we have today. Like today's manufacturing capabilities of today's industries. These are basically uh, a serial-based processing. And what needs to be achieved for Industry 4.0 is that the machines and the facilities, they need to be decoupled. They need to be made modular, autonomous, and yet they are all integrated, networked in a very integrated, in a highly integrated manufacturing process. So everybody is talking to everyone. I'm talking about the machines and the products and the facilities, and they are autonomous. They, without intervention of human, they are able to work. Now, there are six design principles. I'll quickly talk about these. May not have much time to discuss in detail, but later I'll share these slides with everyone so that you can go through. And if you have any question, I'm still connected. Now, these six design principles. The first one is interoperability. So interoperability is like uh, all the components of industry, be it humans, be it machines, be it products, everything is talking to each other. So they're all operating, communicating by each other through internet. So if I'm interested in finding out the status of a certain machine, I'll go to that machine through internet, and I should be able to find out everything happening to the machine and the past and the future. Virtualization is again a big concept that has to be there in the industry 4.0. What we do basically is uh, when we try to create a digital twin of the entire industry. A digital twin means entire processes they need to be uh, developed in silico, or in silico means inside the computer. So you have the entire factory into your computer, and that it does all the simulations. So wherever you want to produce something new or want to make some changes, you can actually do it in simulation and figure out what's going to be the end results. So to validate your hypothesis, to validate your plans, or to see how um, kind of introduction of a new product or improvements in the existing product would uh, be would look like, and how it would affect your business. It can be done through simulation, and that's the virtualization industry. The decentralization is important. As I said, the machines, they need to be modular. They need to be autonomous to make their own decisions. Um, and whatever I'm talking about is just not the fantasy. It has been realized. And there are companies in Germany and Netherlands. They have implemented this industry 4.0 um, to a great extent. So then after decentralization, the fourth design principle of industry 4.0 is real-time capability. So the data has to be collected, and at the same time, it has to be processed as well. Um, is everything okay? Can you hear me? Are you able to hear me? So I'm basically called from one of the organizers. Yes, hello. Is it सब ठीक चल रहा है? हाँ, बस वो लेक्चर चल रहा था. Sure. So, sorry for this disturbance again. So I was talking about the six design principles of Industry 4.0. We talked about interoperability, where people need to interact, people, machines, and facilities. Virtualization is the digital twin of the entire industry, where you can simulate any new concept and improvements that you plan for. Decentralization means that the entire facility, all the big machines in the industry and the people, they should not be dependent on something. They shouldn't be waiting for taking orders. They should be able to make decisions by themselves, right? And then the real-time capability is that there are sensors and they are giving you signals, but if you're not able to catch the signals right at the time, it might be resulting into a big loss or something. If there's a failure or catastrophic disaster going to happen, and then the sensor is trying to tell you something and you're not able to listen to it, the opportunity is lost. So there should be real-time capability in analyzing, collecting and analyzing data. Service orientation, basically, we're talking about uh, customized products giving to the customer And so the entire concept is service oriented. So we try and see what kind of service is required, and we should be able to adapt the entire design of the uh, processes. And then the modularity is, of course, important because something that we have. I mean, there's one facility. It shouldn't be meant for one type of job, whereas same facility should be able to uh, help in other processes as well. Modularity means we have small modules, and there's a basic entity in a module. So putting together all the modules, they can perform a certain operations. Now we once again disintegrate them and join them in a different shape, and now they can perform a different operations. For instance, if you've played with the Leo toys, you can make anything with the Leo toys, right? Similarly, there are CPAs, there are cyber physical systems modules with by putting together they are able to perform a certain type of operation. And once again, if you put them together in a different fashion, they would be able to carry out different kinds of operations. So that's the definition of modularity I'm trying to explain. And that's what we need in Industry 4.0, because we're talking about the customized products and adaptation of resources and facilities that is only possible through modularity. Now, next I'll talk about this building blocks of Industry 4.0 that leads to, um, smart manufacturing and other things. But I guess we don't have enough time. I'll just name these building blocks that make up the Industry 4.0 concept, starting from the big data analytics. Starting from big data analytics. Oops. The next building block is autonomous robots. Then we have simulations. We have horizontal vertical system integration in industry. We have industrial Internet of Things, cyber security, additive manufacturing. So these are all building blocks of Industry 4.0. And uh, I, so what we can do with these building blocks is, like, we can have robot assisted production. We can actually carry out predictive maintenance. We can perform additive manufacturing of complex parts of changing products. We can use machines as service tools, and the quality control can be done, which is driven through big data. So through big data, we are able to, you know, um, find out uh, through big data analysis, we are able to kind of predict the quality, and production line simulations can be done, and the supply network can be made more smart. Um, so the building blocks are further discussed one after the other, starting from the autonomous robots, which are self-sufficient, autonomous. They can make their own decisions. So there are three actions that these autonomous robots would do. They would be able to perceive the environment, make a decision, and then actuate, uh, or make a movement, or make a act or act upon something to realize the required operation. As the digital twin, I talked about this, the simulations that help us visualizing uh, any new concept that we want to make or achieve. And then the cyber security, but I guess it's already time now. But we have one more opportunity to meet again tomorrow, I guess. And so we'd like to take up some questions if we have, and to know to see the questions if we have. Maybe can I see the chat? Okay. So there was one question asked by Pawan, was that which sectors have more employment as well as entrepreneurship opportunities in Industry 4.0? And the answers would be that, see, most
Sir,
of,
excuse me.
yes, Uncle.
Sir, there are actually three questions in the chat box.
Yes.
First is by
Okay.
Mr. Vivek Pandey.
Oh yes, I how could I skip that?
Yeah, yeah,
So it
please.
says that Industry 4.0 techniques replace the conventional machines in future. So they are not replacing the machines as such. All we are trying to do with for Industry 4.0 implementation is that we'll put a